Hi, this is Nikhil Tandon from software engineering. So we're going to be discussing about unit testing in this chapter. I was looking at the notes, so it looks like we're not going to be doing this chapter in class. So I will be discussing it today. Alright, so the topics that we will be discussing today with unit testing, we will talk about assertion, basic unit testing, so like the requirements in unit testing, and also the benefits of it. We also will be talking about exception handling in the basis of JUnit and Mockito. And we also will talk about integration testing, the advantages of integration testing, and also system testing, and give it different types of system testing we will also discuss in this lesson. We will also discuss about acceptance testing and discuss about its advantages and disadvantages when using the concept of basic unit testing. And it's the same thing for system testing, integration testing, and also with exception handling and and assertion. Alright, so we'll just give a little rundown about unit testing. So unit testing is a unit. It can be almost anything you want it to be, like a line of code, in a method or in a class. So obviously we can use methods and classes in any type of code, even if it's like Java, Python, C#, C++, HTML, even JavaScript, or even JavaScript. And basically it's testing the smallest testable unit of application. It is done during the coding phase by any type of developer, coder, programmer, quality assurance, analyst, even if you're doing DevOps as well. To perform unit testing, a developer writes a piece of code to verify the code to be tested and make sure it is correct. If it's obviously not correct, the code's not going to work, but sometimes, we young coders try to figure out as much as we can and honestly don't know why certain things work right away. And that's obviously we're learning about this. That's why we're in software engineering. But generally, though, it's better to have a bit of code instead of making sure it's complicated. If it's complicated, obviously, it's gonna be really hard to read. And if you can make it in a smaller and compact way, it would be better logically and also easy to read. The smaller the test gives you a much more granular view of how your code is performing, and the debugging phase of, or any other person try to look into your work of being a programmer, it would be easier for them to help you make that code better if it is smaller. There is also practical aspects that when you use tests that are very small, your test can be run fast, like 1,000 tests in a second fast. Alright, we will discuss about assertion. Assertion is a very big concept, and it has 3 types of steps that when I was doing my reading about it, it gave me the most basic steps about it. So the range step basically sets an environment and prepares a bunch of objects to run the unit under test. And at the act, it's called like the unit under test basically. And assert checks that outputs and side effects of unit under test are as expected. And assertion is a Boolean expression at a specific point in a program which will be true unless there is a bug in the program. So obviously we know what Boolean is. It's true or false in code. It's either going to give you correct answer or a false answer. It's not really anything different, and it's very easy to debug code that is has a data type of Boolean. But yeah. Also, test assertion is defined as an expression which encapsulates some testable logic specified about a target under test. So here on a line of code that we see, this is obviously C++, as you can see here. Though if you see right here, it says assert. So in this type of code, basically it's calculating. Okay, so it's creating a new object, new calculate, and then there's an integer type result, and it's basically gonna add these 2 numbers. So you see 2 and 3 right here, just a class that was made for this, and they're just using that to do the arithmetic operation of addition. And then it's going to use the class or basically the unit test assert, and basically it's going to give you the answer of basically 2 plus 3 equals 6, or that's wrong over how that person put that specific code. Obviously everyone knows 2 plus 3 is 5. It looks like this image that I found, it looks like this gave us the wrong answer. But yeah, it's alright, no problem. And then we're looking at test method here. This is a method that was created along with the text fixture. So it's an image that I found online, gave a bunch of variables called A, B, C, D with the version class, and then an object called new version had the input of 102010, and then D is the same exact as A, as you can see in this code. And basically they're using the assert function in order for it to be displayed. Obviously you see the true section, that's the boolean aspect of assertion, so you can see that right there. Alright, next thing, we're gonna go, actually I think we went ahead. Okay, so we're gonna talk about basic unit testing again, just to give you a rundown. There are a few reasons that can give you a basic understanding of why a developer needs to design and write out test cases to make sure major requirements of a module are being validated during testing. Unit testing can increase confidence and certainty in changing and maintaining code in the development process. Unit testing always can find problems in early stages in the development cycle. Basically, unit testing code are more reusable, reliable, and clean. That's like basically a requirement in my opinion. But development becomes faster and it's easy to automate. So you can see right here, this is like a basic little diagram of how unit test is basically run down. So obviously to start, so you're gonna add a test. If it passes, then we'll run to the unit test. So it's gonna run then. If it fails, then it just goes back to add test, because obviously you have to figure out what's wrong with the code. And then once you make the changes, you're gonna run it again, and then it will add it, and then you run the test one more time. And then it will stop once it has been ran and finalized. Alright, the requirements in unit testing. Alright, the test should be fast, it should be simple, test shouldn't duplicate implementation, logic must be readable, must be deterministic, make there is a build process. You definitely need to have that, because if you don't have like a build process, and you know, for the end user or someone just not even looking at your code, if you have a build process, they'll be able to understand your code before even looking at it. Alright, and then make sure that you have it appropriate and fast about, make sure you don't use doubles that much, because in my opinion using doubles kind of make everything complicated in code. Just use int or booleans, that should be fine. But yeah, naming should be consistent and appropriate, so whenever you're making your variables, your methods, your classes, your objects, you know, you always want to have like a very sequential, or you know, very easy legible code that you're looking at. And obviously you don't want to add a bunch of implementation details. Obviously you can see right here, like, you know, in this example it says customer requirements, the user interface, the workflow, the process, the function in the data store, and then they correlate with framework objects. The workflow will be the messaging, process will be like the threads, function will be like the classes and the methods, and then data store is like the schemas or the structure. Alright, the benefits of unit testing. Unit tests help you find and fix bugs early. Organizations that incorporate unit testing into their development process and start testing as early possible in the life cycle can detect and fix issues earlier. Your suite of unit tests becomes a safety net for developers. A comprehensive suite of unit tests can act as a safety net for developers. By frequently running the test, they can assure their recent modifications to code haven't broken anything. In other words, basically, unit test helps prevent regressions. Unit tests can contribute to higher code quality. This item is a natural consequence of previous one. Since unit tests acts as a safety net, developers become more confident when changing the code. They can refactor the code without fear of breaking things, driving the general quality of code base up. Unit tests might contribute to better application architects. We'll go back to that later. We're not going to be discussing that right now or in depth. But for now, know that if you can add tests easily to code base, that's usually a good sign regarding the quality of the app's architecture or any program that you were making. So the drive to testable code can be incentive for better architecture. Therefore, you would always want to use the TDD, so it's also called the test-driven development. This can be very effective in your code, or whenever you have basically a team together, like with DevOps. looking at your code or making that a very well-based driven code. Unit tests can act as a documentation. Unit tests are examples of how to use code under test, so you can also think of them as executable specification or documentations. Detect code smells in your code base. If ease of adding unit tests to a code base is a good sign, the opposite is also true. Having a hard time creating unit tests for a given piece of code might be a sign of code smells in code. Functions that are too complex. Obviously, we're not going to really go in detail about that because we haven't given specific videos about that or even examples. But yeah, I don't think we learned that in class as well. All right, exception handling. Everyone has dealt with exception handling. If we learned it in C++, Java, Python. It's a very key concept in coding. And yeah, we'll discuss about it right here. If a method under test declares an exception in its signature, then the test method can allow the exception to parade to a BAP unit runtime. It is best that the test method declares exception so that the possible behavior of method is clear. The test method should not catch the exception. Exception handling is the process of responding to unwanted or unexpected events when a computer program runs. Exception handling deals with these events to avoid the program or system crashing without this process. Exceptions would disrupt the normal operation of a program. There are 3 types of exception: the checked exception, the error, the runtime exception. As you can see right here, Homer, basically with his device, he gets angry, tries to like doit because, the device is not working, or there's some type of runtime error, or some type of error in his device, or when he's coding. But yeah. JUnit and Mockito. So JUnit is a unit testing framework for Java programming languages. JUnit has been important in the development of test-driven development and is one of the family of unit testing frameworks with collectively known as XUnit that originated with SUnit. Mockito is an open source testing frame for Java released under MIT license. The framework allows the creation of testable objects and automated units test for purpose of test-driven development or behavior-driven development. The framework's name and logo are play on mojitos and a type of drink. So as you can see right there, that's the logo of the actual company there. But yeah, we'll go into integration testing. Okay, so integration testing was very interesting in my opinion. It was kind of a little difficult to also understand in this topic, but after taking my time and effort and looking at it, hopefully we'll be able to understand what we're learning here. Okay, also known as integration and testing, INT, is a type of software testing in which the different units, modules, or components of a software application are tested as a combined entity. So basically what that is referring to is basically when you're in code or you're trying to code with your development team, there are specific type of units or modules or even components in the software that you're trying to combine. And when you combine that, obviously it can be complicated, so you have to put that in a specific sequence or make sure they are registered in specific classes and methods. So if you don't use that properly, and basically this step will not run properly, or you won't be able to complete this step. All right. So however, these modules may be coded by different programmers. So that's why you would want to have a specific team do this part, and they have specific parts of it. You wouldn't want one person doing, like a bunch of people doing one specific task. Obviously, that would be more effective, but it would be very time consuming if you do that one by one, because sometimes companies have deadlines, and you wouldn't want that specific end holding everything back. So you'd want to divide everything up equally. But yeah, in their own skill set, obviously. Integration testing is a phase in software testing in which individual software modules are combined and tested as a group. Integration testing is conducted to evaluate the compliance of a system or component with specified functional requirements, and also after unit testing and before system testing. So you can see in this picture right here, you see basically code is the unit testing part. Integration gets combined with the design. And then you see the specifications or like system testing. We're going to be discussing about that in the future slides. You will see that coming up. And yeah, so you can see how it slowly goes down, goes back up, it goes to integration, then goes to system, and then goes back to way down, specification, design, code, back to unit testing. So yeah. Oh, sorry about that. All right. The advantages of integration testing. I'm sorry about that. All right. So independent testing process, high code average, and bug detector. Obviously, everyone knows about bugs, and Windows in your code honestly just ruins everything. It might not work, you might get a virus, someone's trying to gain decode. Yeah, it's just very good, this process, when you're doing it. Also, bugs are not just something bad, it's just something you did incorrectly when you're actually coding. That could have bug. But yeah, it's also incorporated with exception handling as well. Let's take a water real quick, just give me one moment. All right. So the advantages of integration testing. Once again, we're going to talk about independent testing process, high code average, and bug detector. You don't need to wait for all modules to be available and unit tested. So basically, you can do this process without going through the system testing, the unit testing, or even the assertions, exceptionality. You could actually do this beforehand. And if you're doing your code, you do this in the beginning. So that's why you would want one of your people in your development team probably just try to do this step in the beginning, just get over with. But yeah. Alright, so as soon as the relevant allergens are available, quality assurance is something I really wanted to be. So this topic was very meaningful for me, because I would want to obviously learn about these type of basic unit testing, because quality assurance is going up there just like cybersecurity kind of, but this is more of just like code based. It's not like, oh, we're trying to protect the whole company's licenses and modules and like trying to get their specific policies created or in their security policies. Yeah, but yeah, can be proceeded with integration testing. High code average allows a thorough analysis of entire systems, which such as a broad scope, the chance of missing out on crucial connectivity issues is close to zero. So it's very important that you have a specific amount of coverage on this code, or when you're trying to actually debug this specific line of code, or even maybe single line of code or multiple lines of code. So it's very important that you are really scoping or being very interested in your topic regarding this. Bug detector. So it basically detects any defect or security issue during the initial phase of software testing life cycles using integration testing. This saves a lot of time and offer developers superior control over the product. So as again, security is a very big risk in our community, and obviously we are as a senior in Old Westbury, obviously I'm gonna be trying to get into cybersecurity in my future. But yeah, I would recommend that everyone, when you're trying to get cybersecurity, learn about bug detectors, and that would definitely help you in your career, because getting those certs in security is very difficult, and if you don't know that concept, it's going to be very hard for you to proceed in that career or aspect of line or line of work. Next topic will be system testing. I believe this is the final not slide, but final topic with basic unit testing, or the process. But we're not done here, we still got many slides to go. Okay, system testing, also referred to as system level test or system integration testing. It's the process in which a quality assurance team evaluates how the various components of an application interacts together in full integrated system or applications. So once again, that word quality assurance, or that specific job, is very, very important in any type of coding aspect of a company, softwares, websites, databases, having that specific team, or just having a dedicated quality assurance team. And many people are not out there. Many companies don't have that. So I would definitely recommend any company to very highly intensively increase their quality assurance teams out there, and people like us will get jobs. Like, so that's what I'm saying. Okay, system testing is testing conducted on a complete integrated system to evaluate the system's compliance with its specified requirements. System testing takes as its input all the integrated components that have passed integration testing. So as we went back to, let me go to, okay, so, testing checks through code repository. Yes, this is very important too. I didn't discuss this, but it's basically the unit test cycle. It checks out the code from repository, makes the changes, executes the unit testing, fixes defects or re-execute. That would be the integration section, code review, and checks the code into repository. So that's the system testing, and that's part. Alright, so as we were saying, so you know how it just basically we were talking about how basically it has to pass all the tests in basically in basic unit testing. So unit testing, integration, system, that has to pass the test in order for it to be perfect. Alright. Okay, so system testing types, there are functionality testing, performance testing, scalability testing, reliability, configuration, and security testing. Obviously, those basic 1, 2, 3, 4, 5, 6 types of system testing are very important, and that's basically the process how a quality assurance analyst or even specialist has to go through in order for them to fulfill the job and make sure that specific code is working. Types of system testing, also the ones before, but I wanted to go more detail about it. Time. Alright, so usability testing. It mainly focuses on the user's ease to use the application, flexibility in handling control, and ability of a system to meet its objective. Load testing is necessary to know that a software solution will perform under real-life loads. Regression testing involves testing due to be done, make sure none of the changes made over the course of development process have caused new bugs. It also makes sure no old bugs appear from the addition of new software modules over time. Alright, recovery testing is done to demonstrate a software solution is reliable, trustworthy, and successfully recoups from possible crashes. Migration testing is done to ensure that software can be moved from older system infrastructures to current system infrastructures without any issues. Obviously, that's like, even what I'm currently working as an IT specialist, migration in general is very difficult because you don't want to have any type of small little thing ruined, and when you're doing any type of migrations, because sometimes you have a Windows 7 device and trying to migrate something to Windows 11 or 10, certain things might not be compatible, and that specific line of code or those type of drivers or type of syntax errors, like that syntax is not going to sometimes transfer over correctly, and if you don't do that, it's basically no good for the customer to have that device. So yeah, it's the same thing when you're coding, and this specific step of migration testing, it's just going to basically take that specific software and you're just going to migrate it, or take the older version, turn it into a newer version, but keeping the old code at the same time. Alright, functional testing, number 6. Also known as functional completeness testing. Involves trying to think of any possible missing functions. So basically, if there's any missing function, it does the whole test and maybe just adds new functions for you. But yeah, testers might make a list of additional functionalities that products could have to improve during functional testing. It's like, let me give an example. Like when you're getting a car, right? Obviously you want the car to run, it needs to have specific components to run. You always want a steering wheel. But from a 2014 maybe Jeep Grand Cherokee to 2022 Jeep Grand Cherokee, obviously they're going to see improvements, and you would want to test basically if you combine these two. Also, even to hardware, I'm not going to talk about that yet, but yeah, in this example, migration, you're going to obviously want some small old stuff, like maybe like the Jeep logo. You're obviously going to have colors, how it's called, rims, tires. Obviously, you don't want the same thing. Maybe how like the actual system of the car working. And then obviously you would want to have different functions every year, because no one's gonna take the same Jeep model every single time. You know what I mean? Everyone wants a newer version of everything. Just like with phones. Look how much how iPhone has changed their functionality of their phones. But yeah. All right. The last one, hardware/software testing. IBM refers this to hardware testing to homework. It's HW and SW. So HW is for hardware, SW is for software testing. This is when the tester focuses on his or her attention on interaction between hardware and software during system testing. So basically, that's probably just referring to that if you have specific hardware and how that would basically incorporate with that specific software. So if you don't have the compatibility or requirements for that software to run, or you don't have the hardware for that software to run, that's a big no-no, because you don't want that device to crash, get corrupted, or even explode on you. I know, start smoking, because obviously it's not going to work. But yeah, just repeat it. First step is usability testing. Second step is loading testing. Third step is regression. 4 is recovery. 5 is migration testing. 6 is functional testing. And 7 is hardware/software testing. The acceptance testing. This is one of the final, because we had system now have acceptance perfect. So we're just gonna wait till just okay. Alright, accepted testing is a quality assurance process that determines to what degree an application meets an user's approval. Depending on the organization, acceptance testing might take form of beta testing, application testing, field testing, or end user testing. So now we're talking a little about alpha and beta testing with the actual corporation or combination of acceptance testing. All right, alpha and beta testing are examples of acceptance testing. Alpha tested are internal and aim to spot any glaring defects, while beta testing is an external pilot test of product before it goes into commercial production. So basically, alpha is basically doing a small little defects about internally in the program before it is processed to a different end and put out there in the world. And beta testing is basically how someone actually hands-on physically they're testing everything out, seeing if there's any effects on that before it's given out to the end user. This testing technique performed to determine whether the software system has met the requirement specification. So it's like, yes, no, this is wrong, this is right. We're not gonna send this out to the whole world because you don't want to have basically recalls on that specific device. I remember when I purchased a brand new cell phone, like in high school. It was like the Note 7 Plus or something like that. It was like one of the best phones out there, and then it started blowing up, and I'm like, wow, this really sucks. And then I was like, hey, let's just go to Apple, and then no, I'm an Apple user. But yeah. This test technique performed to determine whether the software is met requirements. Okay, the main purpose of this test is to evaluate the system's compliance with the business requirements and verify if it's having met the requirement criteria for delivery to the end user. So as you can see right there, user, software, application, it's accepted, maybe. Then it gets passed to software applications. Perfect. And then you see the product's ready to use for the customer. I see that one failed, and this product is not ready for the customer. All right, we'll talk about the advantages of acceptance testing. All right, guys, just take one more break. All right, encouraging closer collaborations between developers on one hand and customers, user, or domain experts on the other. As they entail that business requirements should be expressed, providing a clear and unambiguous contract between consumers and developers, a product which passes acceptance test will be considered adequate. All right, and though customers and developers might refine existing tests or suggest new ones as necessary. Obviously, you want to keep on testing that product, see if there's any type of issues with that product, so you don't get that product recalled or they start hating on your product outside in the world, right? Decreasing the chance and severity of both of the new defects and regression, defects impairing functionality previously reviewed and declared acceptable. All right, so we will talk about the disadvantages of acceptance testing. All right, so many teams report that the creation of automated acceptance test requirements significant efforts. Some, due to fragile test issues, teams find the maintenance of automated acceptance tests burdensome. The first generation of tools and fitness traditionally resulted in acceptance tests that customers and domain experts could not understand. Customers and domain experts, the primary audience for acceptance tests, find acceptance tests that contain implementations, the details difficult to review and understand. Acceptance tests that are unduly focused on technical implementations also run the risk of failing due to minor or cosmetic changes, which do not have an impact on product's behavior. Alright guys, thank you so much for being with me here today. We're talking about unit testing. I just want to go over a little bit small little things about one more time. In this topic we did talk about what unit testing is, why we use it, the advantages, disadvantages, requirements for it. We talked about assertion. We talked about assertion right here. We talked about the requirements and benefits of using unit testing. You can see it right here. And we also talked about exception handling, checking out like those type of issues in the code and what we use to do it. And JUnit and Mockito is a very big concept that we use today in the world. And then we also talked about integration testing, which is basically the second most useful part of basic unit testing. And then we have system testing, but integration we always talked about. System testing, integration testing, kind of the same thing. That's what they kind of refer to when you actually do the reading about it. But yeah. And then in system testing, we talked about the types of testing. In that, remember, we know those types. It's usability testing, load testing, regression testing, recovery testing, migration testing, functional testing, and also hardware/software testing. And then the final basic unit functionality is acceptance testing, and obviously that's just basically the yes or no for that specific product, if it's it should be sent out there for customers and end users. But yeah, thank you for listening to my video here, and yeah.